All right, guys, let's talk about ACT exponent rule expectations. Now, exponents are not that difficult to follow if you know all of the rules. So here's the thing about exponents. There's a lot of rules. There are multiplication rules, power to a power rule, division, add, subtract. There's a ton of rules for exponents. So it can be very complicated to remember them all. They all kind of jumble together. So let's look at number 1. It says x to the 3rd raised to the 13th is equivalent to what? This is called the power to a power rule because you are raising an exponent to another exponent. So what that means is it's going to look like this: x to the 3 times 13. Power to a power, you multiply. So x 3 times 13 is 39. So x to the 39. You don't have to do anything else. Like, it really is that easy. Now, you can kind of look through some of the mistakes here. So this is what it looks like. So I'll rewrite it because I know my pen bleeds a little bit. So this is what it originally looked like. Excuse me. Let's go through all of the wrong answers because they are really wrong. So B is actually adding these together. So it's got 3 plus 13 is 16. That's actually using the wrong rule. That's using the multiplication rule for exponents, not the power to a power rule. On letter C, they kind of did some weird stuff here. What they did was they took that 3 and they moved it to the front, and then they subtracted the exponents. Subtracting exponents is when you divide. On D, it's kind of similar to C. They moved the 3 to the front, and then they just brought the 13 down. Then on E, it's a combination of C and D. They moved the 3 down, and then they added 13 and 3. So there's a lot of ways to do exponents wrong, and when you see all these answer choices, you're probably going to be like, I forgot. Like, I had a good grasp on it, but now I've kind of forgotten how to do it. So just practice the rules. So let's look at number 2. Again, x to the 4th is being raised to the 15. So my mind should think I got to multiply those exponents. Again, power to a power. So x to the 4th times 15. So 4 times 15 is 60. So the correct answer is H. It just takes time. So remember, this is called the power to a power rule. Power to a power. It's an exponent raised to another exponent. All right. 3. Which of the following is equivalent? And that looks like a horror show, doesn't it? I mean, look at that exponent in the first problem. Exponent of 216 and 729. Like, that just right there looks so intimidating that you might second guess yourself and go, oh, that could be the right answer because it looks so wrong. So here's the thing about exponents. You have to pay attention to GEMMA, okay? So again, GEMMA's not going away. So that's grouping symbols, exponents, multiplicative operations, and additive operations. So I'm going to look in my grouping symbols first. I see some parentheses. I can't do anything in those parentheses exactly, but I do see some exponents, so can't do anything in grouping. Then I see an exponent outside of my parentheses. So I know that I want to start with exponent. Well, this first one, I cannot, okay, do not distribute this over here, okay? I'm pretty sure that that's how they get A. I haven't actually worked it out incorrectly, but I'm banking on the fact that might be somehow how they get A, or they're either like multiplying all these numbers together. Don't really know, okay? So let's try to do this. The first one, I'm going to leave 3x cubed y to the 4th because I can't do anything with it. But the second one, I have that cubed outside. I can distribute the cubed to everything. And what that's going to look like is negative 2 to the 3, x squared to the 3, and y, what was that? Y to the 5th raised to the 3. Okay? I can do power to a power rule. Now, you cannot distribute an exponent if the numbers are being added. This only works for multiplication, so I can't distribute an exponent. So, for example, this right here, This has nothing to do with this problem, but just so you know, you cannot distribute the squared and get x squared plus 4. Okay, that is incorrect. However, if it's multiplying, you can. Addition, no. Okay, if there is an addition sign right here, you cannot distribute the squared. All right, so let's go back to our problem. So we have 3x cubed y to the 4th. And now I'm going to start simplifying. So again, a great example of why they want to trick you on the ACT. They're making you cube a negative. So I'm going to make sure that I put it in parentheses. Now, anytime you raise a negative number to an odd power, it will always be negative. Okay, that's true. It's the even powers where the signs mess up. So if you're raising any number, positive or negative, to an even power, your answer should always be positive. If you're raising a negative number to an odd power, it should always be negative. Okay, so just be mindful. A negative number to an even power is always positive. A negative number to an odd power is always negative. So my answer is -8, which is correct. Then I'm going to use the power to a power rule. I'm going to multiply. My x value here, x to the 2 to the 3. 2 times 3 is 6. Then I have y to the 5 to the 3. 5 times 3 is 15. Now, I think maybe where they're getting some... No, I still don't know how in the world they got A as an answer choice. I'm still floored by it. I keep trying to work through it and see where they might have gotten that, but I honestly don't know. So if you know, please tell me in class or type it in the comments, because I would love to know how you get A. Okay, anyway, back to the problem. So since all of these are on the same level, I'm just multiplying them. So I'm going to use the multiply rule. So I can take 3 times -8. Well, 3 times -8 is -24. So I'm going to pause here and look at my answer choices. I see a -24 here and a -24 here. So I know that those other answer choices are wrong. Okay, I know that they are incorrect. I don't know how A is incorrect, but I know it's wrong. Okay? So I know that I should get -24. Now, when you have exponents and you're multiplying the exponents, they're on the same level, just x to the 3. So I'll move them over here. X to the 3 times x to the 6. What you do is you add them. So this becomes x to the 9. So it looks like this. X to the 3 plus 6 is x to the 9. So what's happening right here is I should be adding my exponents together. So x to the 9. So I'm going to pause and look at my problem, and I see that I have an x to the 9 right here, but I have x to the 18 right here. So that lets you know C is out and B is the right answer. So again, I should put, no, I don't need a plus, I'm sorry. So just be mindful that you do not have to finish the problem. Once you find the answer and you know without a doubt that that is the right answer, stop doing the problem. You don't get points and bonus points for doing more work than you need to. All right, number 4, for all non-zero A and B, that just lets you know that the bottom of the fraction can't be 0. 13a squared b to the 4th times -8 a to the 3 b to the 5 all over 4a squared b6. So what you want to do here, you don't want to divide first, okay? No dividing first. Let's go ahead and simplify the top. Now again, this problem looks exactly like this problem up here in the numerator of this fraction. So we're going to be using the multiplication rule for exponents. Remember, if the x's are on the same level, if the exponents are here, same level, they're not being raised to each other, you just add them, okay? So let's do that for the first one. So I'm going to do 13 times -8, and 13 times -8 is -104. Okay. And then I have a squared a to the 3. 2 plus 3 is 5, so a to the 5. Then I have b to the 4th and b to the 5th. 4 plus 5 is 9, so b to the 9. All over 4a squared b6. So I've used my multiplication property when it comes to exponents. Now I must use my division property when it comes to exponents. So the first thing I want to do is simplify everything I can. So I see that I have a negative 104 and a positive 4. So let's just simplify that. 104 divided by 4 is negative 26. And since the negative 104 is larger, it's going to be on the top of the fraction. So negative 26. So I'm going to pause, look at my answer choices. I see a negative 26 here. I see a negative 26, but it's on the bottom, which is bad. Then I see this could be on the top of a fraction, and this is on the top of a fraction. So I can go ahead and eliminate A and C. And now I have a 33.3% chance repeating, chance of getting it right. Okay. Now the division rule is subtraction. So what you want to do is match up the exponents, and they have to be positive to do this. You match up the exponents and you look, you say, okay, 5 is here, 2 is here. 5 is bigger than 2. So that means the A value is going to stay up top. It stays where the exponent is larger. And then you subtract. 5 minus 2 is 3. So now, right here, all I've done is simplify, and I got A to the 3. I'm going to look at my answer choices and see, okay, I've got A to the 3 here, and that's it. Nowhere else do I have A to the 3. So you know what? I found my answer. But we can continue to finish the problem just to make sure we know what we're doing. Again, right here, I see that I have, let me grab another highlighter color. I see that I have a B to the 9 over B to the 6. Well, the 9 is larger in the numerator, so that means B will stay up top. 9 minus 6 is 3, which is, again, answer B. All right, let's keep on trucking. For which of the following expressions is equivalent to 1/2 x squared y to the 5th? Okay, do not be intimidated because there is a fraction being raised to a power. We talked about fractions in class. Remember, the power gets distributed to everything. So the 5 can go here, here, and here. You have to use like 4 different rules on this problem. So it is tricky, but it's nothing that you haven't seen before, okay? You know how to do all of these problems. So let's separate it. So I know that this is 1/2 raised to the 5 times x squared raised to the 5 times y to the 1st raised to the 5. Break it up, okay? If it looks hard, break it apart. Make it easier. So when I'm raising a fraction to a power, I distribute the power to the top and to the bottom. So this now becomes 1 to the 5th over 2 to the 5th. Okay, we can continue to simplify if we want to. So I know 1 to the 5th is 1, 2 to the 5th is 32. So I have 1 over 32. So again, this got cut off in my answer key making. Sorry. So I'm going to pause and I'm going to look for the answers of 1 over 32. I see it in option C and D. So right off the bat, again, I can narrow 3 of my choices down, and I am sitting pretty at 2 50-50 chances of doing this right. So I got 50-50 chance of doing it right. All right, now comes the part where we might not remember. So notice here, we have y to the 1 basically raised to the 5. We know that this is going to reduce to y to the 5th. Okay, we know it because 5 times 1 is 5. Notice how both of these still have y to the 5th in them, so we can't get rid of anything. But what it comes down to is, do you understand the power rule, like the multiplication rule, or power to a power? So if I look here, I know that 2 is being raised to the 5, which I should know that I multiply them together to get an answer of x to the 10. 2 times 5 is 10, which is option C. However, if you forgot and you add them, okay, they're trying to trick you. They're trying to put doubt in your mind so that you say, I don't remember what I learned in class. So this x squared to the 5, okay, this is just a little side note. X squared to the 5 is the same as x squared times 5, yes, x squared times 5. See, I put my own doubt in my mind. Oh my goodness, that's embarrassing. Oh well, x to the 10. They want you to do it like this. They want you to think of it like x squared raised to the 5th. They want you to think that you do x squared plus 5. They want you to think that it's written like this, x squared x5. Okay? This and this are not equal. This is when you add them to get x to the 7. We don't want to use that. Power to a power, multiply. All right, number 6, the product of 3m5n to the 7 times negative 4m n to the 3rd is equivalent to what? Again, basic. This is basic. We were just doing harder problems literally right here. This problem is way harder. It's basically just the top and you're done. So looking at 6, 3 times 4 is negative 12. And looking at my answer choices, I can't eliminate any. But now I have m to the 5th times m to the 1. So 5 plus 1 is 6, m to the 6th. Now I can stop and say, okay, the only one with m to the 6th is option K. Then I could finish. N would be 7 plus 3, which is 10. Now on number 6, be really careful. They purposefully don't put m raised to the 1. They just leave it as m. You have to know that it's to the first power. You have to add them. So m to the 6th. If not, you would have chose option F, where they ignore the 1 raising right here to the m. Okay, so be careful. They're purposely putting it tricky, and notice that that answer is first. So if you forget to do it first, you're going to be like, oh my goodness, and miss a very easy question. Okay, personally, on number 7, I personally do not like the way that this problem is written. And that is just personal preference. I think that this times symbol should not be written as an X, it should be written as a dot. And that to me, that is just personal preference. I don't like when we use X to represent multiply because I think it can be confusing, especially in higher level math, whenever you have a variable with it, and it's very easy. I know that you can tell that that's cursive, but it's very easy to confuse them if you're in a rush or if you feel panicked. So I don't like this particular practice problem. I did get it out of an ACT practice book, so I mean, it could be on an ACT, so just be mindful that could happen. I personally don't like it, but I guess the ACT didn't really ask me what I liked. So let's go ahead and try this problem. So right now we have a fraction, and we have times this other piece over here. I would recommend just going ahead and simplifying this fraction first if you can. So let's go ahead and simplify just this fraction. So I'm going to rewrite it down here. And x squared y z 4. Okay, so I'm just going to kind of ignore this part for now. I'm just going to simplify this fraction. So I see the 3. I'm going to keep the 3 in the numerator. My 5 is larger on top, so 5 is going to stay on top. So x to the 5, x to the 2, 5 minus 2 is 3. Y is larger in the numerator, so it will stay up here. I have 3, and this is a 1, remember, so 3 minus 1 is 2. And then the z value is larger in the bottom, so 4 minus 1 is 3. So I've gone ahead and simplified that fraction, which is great. Now I'm going to multiply x cubed y3z. Now, one thing I want to make sure that you know is we're multiplying a fraction here. So I need to put this over 1. And the reason I put that over 1 is to make multiplying by the numerator a whole lot easier. So I'm going to go ahead and multiply. Top times top, bottom times bottom. So z to the cube times 1 is just z cubed. 3 can't multiply, 3 can't multiply to anything, so it's just going to be 3. I've got x squared, or x cubed and x cubed, so 3 plus 3 is 6. Remember here that we are not going to waste our time and do the wrong method here. I don't multiply the 3s, I add them because they're on the same level. And then I have y squared and y3, so y squared plus, or times y cubed. I add the exponents to get y5. And then my z just kind of floats here. I'm going to make sure to pay attention for simplifying. So I notice that I see a z in the top and bottom, so I'm going to simplify again. Again, I notice that z is bigger in the bottom, so 3 minus 1 is 2, so z to the 2 must be in my denominator. Then I have 3x to the 6th, y to the 5. which is option D. So just be mindful. You could, up here at this top part, you could have just put this over 1 and multiplied all the way across if you wanted to. It's basically the same amount of work regardless. It's just your life choice, what you want to do, what you feel comfortable with. Okay, number 8. For any real numbers, a and b, 10a squared times 5ab times 2ab to the 4th is equivalent to what? So the first thing we should make sure we know is that all of these are on the same level, so we're not going to use power to a power rule, we're going to use multiply. So looking at our answer choices, I see 10, 5, and, or not answer choices, sorry. I see 10, 5, and 2 as my coefficient values. So I'm going to multiply them. Notice how C, D, and E has you adding them. 10 plus 5 plus 2 is 17. We should know immediately that those are wrong. Take the time to mark them wrong. Get them out of your way so now you have that clear 50-50 shot of doing it right. So 10 times 5 is 50 times 2 is 100. So I've already narrowed it down 50-50 just by knowing how to multiply a number. Next, I have a's. So I have a squared, a to the 1, a to the 1. Okay? Notice option B, they just make you want to think that we should be multiplying or that we don't do anything with these 1 values by a. We do. We add 2 plus 1 plus 2 is 4. So the correct answer is A to the 4th. On option B, they bank on the fact that you're going to forget about the 1s because they're not written. And just because they're not written doesn't mean they're not there. So I have another one right here, B to the 1, B to the 4, which is B to the 5. So just be mindful, the ACT will do anything to make a hard problem or an easy problem difficult, and just by putting doubt in your mind. Okay? I love problem number 9. I think that problem number 9 is a great problem because it's a little complicated, not gonna lie. It's a complicated problem for the ACT. It's gonna take a little time, and this, I just like it from a teacher perspective because you have to really think to be able to do number 9 correctly. So number 9 is a great problem. So it says, which of the following is equivalent to 1 over 4m to the 3rd raised to the negative 2? So this is such a great problem. I'm excited to do this. Super nerdy. All right, so whenever you have a fraction raised to the exponent, everything gets raised. So we all know that. So this is going to be 1 to the negative 2. Now at the bottom, I'm going to purposefully write it like this. The reason I am writing it this way is because it's a little easier. And I need to remember that the negative 2 goes to everything. All right, now, the rule with negative exponents, if they're negative, they're not happy where they are. They're negative. So you got to move them to make them positive and happy because they're unhappy where they are. They're negative. So any kind of negative exponent, you shift it to the opposite section. So like 1 raised to the negative 2 is unhappy. It's negative in the numerator. It will be much happier and positive in the bottom. That's where it wants to be. It doesn't want to be on the top. Same thing with the denominator. I have 4m to the 3 all raised to the negative 2. That as a whole is not happy in the bottom. So I got to shift it up here. And by shifting it, it changes its attitude and it's happy. So now I'm going to simplify. My 4 is going to be squared, and my m to the 3 is also going to be raised to the 2 all over 1. 4 squared is 16. M to the 3 to the 2, so notice right here, power to a power, 2 times 3 is 6. All over 1, which is the same as 16m to the 6th, which is option E. Excuse me. So I just love this problem just because it's tricky. I mean, it really is hard. But when you know the rule and you feel confident in the rules, it's when you will do better. So practicing the negatives, things like that, it makes it a little bit easier. All right, number 10. For a real number m, 2m to the third, all raised to the 4. We got this. The 2 is going to go to the 4, so I got 2 to the 4th, m to the 3 to the 4. 2 to the 4 is 16, so right off the bat, I got a 50-50 shot of doing it right just by knowing that 2 to the 4 is 16. And then again, they try to trick you. Option D, they're adding 3 and 4 to get 7, which is wrong. Option E, they're using the power to a power. 3 times 4 is 12. So the answer is E. Don't get tricked, you can do it. All right, let's try the last one, number 11. The product, so right here, nothing is being raised to an additional power, so I'm just going to use the multiply rule. Negative 4 times negative 2 is positive 8, so E is out. 6, x to the 6 times x to the 1, 6 plus 1 is 7, x to the 7. B and C are out. Now, notice B and C have x to the 6th. It's because they want you to forget that there's a 1 here. Don't forget. Don't let the ACT trick you and take benchmark away. All right, now on number 11 on A and D, option A is correct. So I've got y to the 7 and y to the 3, so 7 plus 3 is 10. So the correct answer is A, but don't get tricked by D. D multiplies 7 times 3 to get 21. That's the wrong rule. So they are purposefully going to use the incorrect rule to put doubt in your mind, but you are smarter than that and you will rise above. So just be mindful that the ACT is out to trick you, and as long as you know the rules, you're going to be just fine.